So one of the neat things about this big shape is that it allows you to explain the connection between the volume of the tetrahedron, the small tetrahedron, pick that up, and the volume of the square pyramid with the same side lengths. It allows you to explain the connection between those two volumes without actually doing any calculations of the volumes themselves. And so what is the connection between the volume of those two shapes?
So the square pyramid has twice the volume of the tetrahedron.
Okay, why?
Well, you can see that in here because this big tetrahedron, the three-dimensional scaling rules for volume. So for instance, for a cube, if you double the side lengths, you get 8 of those small cubes.
Okay.
And it's the same for the tetrahedron, the volume. So if you doubling all the side lengths, you'll get the equivalent to 8 small tetrahedrons.
Okay, so if we double the side lengths of the tetrahedron, we get a volume that's 8 times as much. So the two tetrahedrons, can you put your hands on them? So show those two tetrahedrons, one is 8 times the volume of the other. Okay?
And here we only have 4 tetrahedrons here. We've got 4 tetrahedrons and an octahedron.
Alright, and what's important about the octahedron?
Well, that's the rest of the volume of the tetrahedron, the big one.
Okay.
So that means the octahedron has 4 times the volume of one of these tetrahedrons.
Alright, so the octahedron with the same side lengths has 4 times the volume as one of the tetrahedrons.
So that must mean if you divide the square pyramid, if you put 2 of them together, you have an octahedron.
Okay.
So the square pyramid has to have twice the volume.
Twice the
Okay.
volume of one.
So it has to have twice the volume of one. And this is a little bit surprising. So get the other two shapes out of the way. Just leave the tetrahedron and the octahedron, or the pyramid, I mean. Okay. Does it look like one is twice the volume of the other?
No.
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 It looks like this is less than twice.
Alright, what would you guess it was?
I would have guessed like 1.5.
You would have guessed 1.5, and what was your guess? Do you remember?
I think it was like 1.1.
1.1, yeah. So interestingly, when you have these two shapes in your hand here, and maybe I can zoom in on them for purposes of the camera. It just doesn't look like one's twice the volume of the other. In fact, the tetrahedron's a little taller, right?
Yeah.
So the pyramid itself has a bigger base, but the tetrahedron's taller. So it just doesn't look like they're double, but we're going to do an experiment today to test this. So we're not doing any geometry and we're not calculating any volumes. We're going to test it by filling them with water and making measurements. Okay?